of you welcome in the fluid mechanics lab of the fourth semester. So today we will introduce the lab regarding that is the whatever that is the experimental setup is available here. So let us begin. चलो.
Metacentric वाला. Good morning, students. Actually, in this semester, we have to study about the 5 experiments of fluid mechanics. Okay, and we have 5 experiments. First, we have to calculate the metacentric height, and for that, we have this is the setup of metacentric height. This is the tank we have, and this is the ship model in which we will calculate the metacentric height. And from here we have the flow meter devices from which we can calculate the flow, and also we can calculate the volume displaced by this meter. And this is the reading to calculate the angle by which the ship is tilted. And the next experiments we have is Bernoulli's experiment. Okay, so in this we will verify the Bernoulli's experiment. Is it visible? Anybody confirm, please?
Yes, sir.
Okay. Are you able to see the whole setup?
Not clear, sir.
No, sir. Everything is
Okay.
blur.
Okay, okay. Now,
Sir, we are just able to see the structure, but can't understand clearly what it is.
yeah. When we calculate, now when we do experiments, I will make you understand all the things. Whatever where we have to calculate the readings and what means everything we will do. Okay, and which things is for what purpose we will discuss there. Today is only introduction about the experiments what we will do. Okay, so don't worry about all the things. We will make you understand all the things when we will start the experiment. Okay, understand?
Yes, sir.
Okay. So this is the and the next we have Reynolds. The Reynolds setup is actually I already discussed you that we have 5 experiments, and this is the third experiment we have to do. This is Reynolds apparatus. Anyone can tell me about that? What Reynolds experiment? What is the significance of Reynolds number?
It tells about streamline and turbulence.
Yeah. It tells about whether the flow is turbulence or laminar. Okay. So in which we have the flow meters where we can see the whether is the here. This is the pipe. In the pipe we will inject some dyes. Okay. Do you know dyes? Here we will fill dye. Dye means one color pigment, and by that color pigment we will actually uh, uh, see the flow by this pipe. Okay, if the dye flow is in a streamline, then this is laminar, and if the dye flow is in just wavy and means there is no any pattern, then this is turbulent, and by which we will calculate the flow, and next we can calculate the by that flow we can calculate the Reynolds number. Okay, and the fourth fourth experiment we have that we have to calculate the friction in pipes. Anybody can tell me the formula to calculate the frictions in pipe? Hello, am I audible?
Sir, you are asking about viscous force.
No. Means this losses in pipe. Have you studied about the losses in pipes till now?
No, sir.
No. Okay, no problem. When we will see, then at that time we would have gone through that. And this is the experiment. We will calculate the what the losses in pipes. This is the actually manometer to calculate the pressures. Okay, and by this we discharge the air from the manometer, and this is the tank we have in which we calculate the uh, actually mass flow rate by this tank, calculating the time and the volume and multiplying, actually dividing the volume with the time, we will get the flow, means whatever the discharge. Okay, and the last experiment we have, last experiment, notch. We have last experiment which is flow through the different types of notches. Okay, this is open channel flow setup, and we will calculate different types of flow by changing the notch angle and the notch parameter. Okay, this is the vernier caliper for the measurements. I think you already know about all the things. This is the tank to calculate the flow. We have some readings. Okay. So I think from the next week we will start the experiment, but with the metacentric height. First we will calculate the metacentric height. Okay.
क्या ला ला रहने दे
Front camera.
हाँ फ्रंट कैमरा तो मेरा सब कर दिया जाएगा बैक कैमरा ही रखते हैं So dear students, so these are 5 setup are the ready and 3 setups are under process for the purchase. So first we will conduct these 5 experiments. However, in the last, that is there are 2 types of the notches. One is the rectangular, another one is the triangular. So that, but we will include that is the only in that one setup. Here you might be seen. See, so this is the here triangular is that is the node that is available here. If we will replace it and then it behaves like or treated as a rectangular node. So we can use this one. So first that is these 5 setups that is we have to perform the experiment in the from the next week. After that, and then we will 3 that is the machines are coming in the process for the purchase, then we will do. Otherwise we will study some setups, some measuring device, flow measuring devices we have to the study, or in the turbine that is if it is visible turbine in flow devices are available there also, so we can measure it. Is it correct? So in that is this lab, first you should make purchase a small notebook, a small copy for calculations, a small copy, reading hardly 10 page or 20 page. One lab report you may purchase, and that is you have to write, or it is better you may write in the soft copy and send to the our mail. Is it correct? In the that is the next day or next week, that is the accordingly. So the experiment performance day, you have to just tally the result. At least one result we should check you. So you confirm from that is the, your calculations, and then we will see it, and then rest calculation similar pattern you may complete it. So this is the way of the conducting the experimental setup. And lastly we will call your, that is the roll call, because roll call, that is attendance performance is also important. So 5 to 10 marks, that is the comes from the attendance, some comes from, that is the viva, 20 to 30% the viva or more. Your performance, that is the in lab or in, that is the your thesis, some, that is report submission, all these gives, that is the 2 credit. So I hope you must take or enjoy the lab, and you can't leave this one. That is the, don't miss the lab and don't neglect the lab. This is a very interesting thing, and that will help you in, that is also in fluid machinery part. And I, so before coming to the lab, you just go through the setup, through the manual. We will send you the soft copy of the manual. Just read it or take the help from the book. What is the metacentric height? How we will perform? What is the purpose? What is the precaution? Just before coming to the lab, you go through the manual, and then you should perform the experiment. If you have any query, then ask me. If you have not any query, then still you should wait 1 hour for the lab, and unless until calculation is completed, till that is the, we will give the attendance. So the lab that gives, say, that is the practical idea. However, it is the visualization, virtual, but still you can feel it. If you should get, or if our institute will open, then you may visit the lab and I can conduct again, no problem. You may see it actually. But right now, that is the, we have started the our lab. So let us suppose you have any query, then ask me regarding the lab. If anybody have any query, then you may, that is the ask. If anybody not seen, that is the experimental setup, then you can also see, you can visualize you. So, so in, that is the Reynolds number. Here see, this is that is the a dye providing system, a D in this, the providing the a tube in the pipe that flow the dye. And straight line flow, a streamline flow means laminar. If that is the zigzag mixing, not in a straight line, not in a streamline means flow, that is, that will become turbulence. And turbulence means more velocity. More velocity, here discharge we will enhance, increase. Area of the pipe is fixed, so obviously velocity will increase. From conservation of mass, area gune velocity, for incompressible flow, velocity will enhance. Reynolds number will change. Reynolds number is rho v l by mu, or L is replaced by the D in case of the closed conduit, or in the open channel it is treated as the characteristic length. So these are the some parameters. So before coming to the lab, you must go the terminology, because it is not possible to teach all whole the syllabus within the 1 week or 2 week, but your lab have to perform before the completion of the theory. So just coming to the lab class, you go through the from the book or manual which we will provide. So let us, we are going to call you, that is the attendance. Please give your the attendance. Yes. Call करो एक आदमी।
Roll number 1.
Present, sir.
Roll number 2.
Present, sir.
Roll number 3.
Present, sir.
Roll number 4.
Present, sir.
Roll number 5.
Present, sir.
Roll number 6.
Present, sir.
Roll number 7.
Present, sir.
Roll number 8.
Present, sir.
9. 10.
Present, sir.
11. 12.
Present, sir.
13.
Present, sir.
14.
Present, sir.
15.
Present, sir.
16.
Present, sir.
17.
Present, sir.
18.
Present, sir.
19.
Present, sir.
20.
Present, sir.
21.
Present, sir.
22.
Present, sir.
23.
Present, sir.
24.
Present, sir.
25. 26.
Present, sir.
27.
Present, sir.
28.
Present, sir.
29. 30.
Present, sir.
31.
Present, sir.
Roll number 9 present. Mic not working. Roll number 9. 32.
Present, sir.
33.
Present, sir.
34.
Present, sir.
35.
Present, sir.
36.
Present, sir.
37.
Present, sir.
38.
Present, sir.
39.
Present, sir.
40.
Present, sir.
41.
Present, sir.
42.
Present, sir.
43.
Present, sir.
44.
Present, sir.
45.
Present, sir.
46. 47.
So see, so all are you present here? So first you write the name of the experiment. All of you please write the name of the experiment. Experiment number 1.
Experiment number 1. Are you writing? Should I dictate?
Yes, sir.
Okay. Experiment number 1. To determine experimentally the metacentric height of a ship model. Experiment number 2.
Slowly.
Okay. I have to repeat. Okay. To determine experimentally the metacentric height of a ship model. Done? Everybody? Experiment number 2. To verify experimentally the Bernoulli's theorem. To verify experimentally the Bernoulli's theorem. Experiment number 3. To study the flow parameters. To study the flow parameters in the bracket laminar and turbulent. Bracket close. For flow through a pipeline. To study the flow parameters in the bracket laminar and turbulent for flow through a pipeline. Experiment number 4. To determine the friction factor, for Darcy-Weisbach, Darcy spelling D-A-R-C-Y, Weisbach W-E-I-S-B-A-C-H equation. To determine the friction factor for Darcy-Weisbach equation. Experiment number 5. To determine the coefficient of discharge, through different types of notches, in which we have first rectangular notch and second V notch.
All of you written the name of the experiment?
Yes, sir.
Yes, sir.
Yes, sir.
Acha, okay, so any that is so let us see in the first 5 that is the we will conduct, then later on we will rest 3 conduct. Any query then ask me. किसी का अटेंडेंस मिसिंग है, किसी को कोई बाद में ज्वाइन किया है? कॉल करो तो
60 तक ज्वाइंड है
सर 60 तक ज्वाइंड है।
ओ 60 तक कॉल करो, 60 तक
47 तक
47
चला गया बाहर।
रोल नंबर 47
हो गया था। तो हो गया था 48 बोलो।
48
प्रेजेंट सर।
49 50
प्रेजेंट सर।
51
51 present, sir.
52 53 54
Present, sir.
55 56
Present, sir.
57
Present, sir.
58 59
59 present, sir.
60.
प्रेजेंट सर
Okay. Anybody have not given his attendance, please call once. Okay.
Any query, students? So this is all about your introduction class of the fluid mechanics in the, so we will conduct again the next week, and class is from tomorrow I will take. Okay, thank you.